Hey guys, today we're going to take a look at the derivative of exponential functions. So this is not something we've previously done up until this point. You know, it's been things that have involved polynomials or rational functions. So we're going to look specifically today at e to the power of x. Okay. What are the properties of this function? Well, you may remember from advanced functions that first of all, there is a horizontal asymptote. And that's at, well, let's zoom in so it's a little neater. But that's going to be at y equals 0. Okay? At y equals 0. So it's a horizontal asymptote, and it is, of course, the x-axis. Okay? Furthermore, as x approaches infinity, y is going to approach infinity. So even though as x approaches negative infinity, y approaches 0, as we approach infinity with x, y is also going to continue to get bigger. And what's perhaps most important for this one is that as we approach, or so also as x approaches infinity, okay, the line's going to get, or the curve's going to get steeper and steeper and steeper. Okay, so the slope will increase. Okay, and it will just continue to increase forever. All right, so we're going to do our sketch on here, and I'm not going to be super accurate necessarily, but there are a few key points. So first of all, we're going to have the point 0, 1, which I should probably do on the right point because that's 0, 2 there, but there we go, 0, 1. Okay, and then beyond that, whoops, I don't know what I just did. All right, we're going to go down and down and down, go closer and closer and closer, and you can see the slope of that line is getting closer and closer to 0. But then as we go in the other direction, we're going to get bigger and bigger and bigger, and that slope is going to continue to increase. All right? The significance here is that if we were to sketch the derivative, and I'll do this in green here, if you look at it, if you think about it, this is getting closer and closer to 0, so the slope is also getting closer and closer to 0. And as it gets steeper and steeper and steeper, the derivative is also obviously going to get steeper and steeper and steeper. And what you'll notice is that the two graphs are actually identical. And so that's actually what's so, neat about e to the power of x, is that the derivative of e to the power of x is just e to the power of x. So, if f of x equals e to the power of x, then f prime of x equals e to the power of x. So, it looks like a difficult one to work with, but in actual fact, it ends up being the easiest derivative you're going to do all year because it's exactly the same. All right, and we can use this with our other rules. And so, for instance, this first one, we're just going to use the product rule here. And so, I'm going to call this f of x. If I call that f of x, then f prime of x, we're still just going to use our product rule the same way. And we say the derivative of x squared is 2x. And then we have e to the power of x plus x squared times the derivative of e to the x, which is just e to the x. All right, so that's all there is to it. All right, and we can use the chain rule as well. All right, so if we have this, so again, I'm going to, well, for fun, I'll call this one g of x. I don't know how much fun that is, but I think it's fun. So we take the derivative of that. We're going to start by just taking the derivative with respect to x over 2, which is just e to the power of x over 2. But then we're going to multiply by the derivative of x over 2, which is 1/2. Okay, so we can simplify that. You wouldn't necessarily have to, it would depend on the context, but you're going to get that. So it's just 1/2 of the exact same function. All right, and almost exactly the same here. I'll go back to f of x. Okay, when we take the derivative of this one, you're going to start and you're going to take the derivative with respect to with respect to negative x. So we get e to the power of negative x. And then we're just going to multiply by the negative x, which is just negative 1, or by the derivative of that. So there we go. So we're just left with negative e to the negative x. All right. So, sort of the rule of doing composite functions. So this is when instead of an x you have another function. And again, it's just the chain rule. It's no different. Okay. You're just going to have. So we'll say. Actually, let's go. Let's say if. That wasn't supposed to be if, but that's okay. If f of x equals e to the power of g of x, then f prime of x, I'll write then too, then f prime of x is equal to e to the power of g of x times g prime of x. All right, so in other words, you just write down exactly the same thing you had, but then you have to multiply by the derivative of that exponent. Okay? And that's all there is to it. So we're actually going to take these 6 questions, and those are going to be your warm-up at the beginning of class. So until next time, go Sabres!